Hello, my name is Necati Cihan Camgoz, and today I'll be presenting our paper SubUNets, end-to-end handshape and continuous sign language recognition. In this paper, we propose a novel deep learning approach to solve simultaneous alignment and recognition problems, commonly known as sequence-to-sequence learning. We decompose the problem into a series of specialized expert networks, which we named SubUnets. Our approach mimics human learning as it allows us to inject domain-specific subunit level knowledge into the system regarding suitable intermediate representations. SubUnets also allow us to implicitly perform transfer learning between different interrelated tasks, which also enable us to exploit a wider range of more varied data sources. This approach is applicable to whole domain of different computer vision problems, where tasks can be broken down into a number of more tightly constrained problems. Subunit Architecture is a formalization of CTZ-based sequence-to-sequence learning, which uses CNN-RNN hybrids to learn spatio-temporal features. In our work, we investigate different ways of combining subunits, which learn complementary information while they are being trained jointly in an end-to-end manner. We evaluate our approach in the challenging domain of continuous sign language recognition, where systems are expected to detect and recognize individual signs in a given video. We chose this domain because it's particularly well suited to our subunit approach, as unlike spoken languages, sign languages are famously multimodal. Additionally, there is a wealth of expert linguistic knowledge relating to sign languages and interaction between its different modalities. To demonstrate the advantages of guiding networks to learn expert knowledge, we propose two architectures for continuous sign language recognition. The first architecture is a generic network, which is trained to recognize signs from hand patch and full frame sequences. The second architecture is what we call the expert network. Although it takes the same inputs, it learns intermediate handshape representations via multiple loss layers while being trained to recognize signs in continuous streams. We trained our continuous sign language recognition networks using Phoenix 2014 German weather forecast dataset. In our experiments, the expert network that learned intermediary handshape representations outperformed the generic approach. Our expert networks yielded better results on the test set while achieving more balanced deletion-insertion ratios, indicating a more balanced training. In addition, our approach was the first end-to-end continuous sign language recognition method, which did not require any alignment procedure, and it obtained comparable results to the state-of-the-art methods. We also conducted experiments to evaluate the performance of our hand subunit, which learns to recognize hand shapes from hand patch sequences. We trained our hand subunit on the challenging 1 million hands dataset. In our experiments, hand subunit achieved state-of-the-art performance by surpassing the previous CNN-based approach. Furthermore, we ran our hand subunit on another sign dataset from a different language and a different domain, and it was able to align and recognize hand patches successfully. Thank you for listening, and we would love to see you at our poster, session 5 and board 12.